Hello and welcome to the channel Understanding.Concepts.Of.Physics, and today here we are with another numerical on oscillations, and you can pause the video and go through the question. This is one of the very nice questions where very unique questions, like if you are able to identify if the problem is from oscillation and if they are asking us time, then there is one formula which we can use repeatedly. So let's see. So I'll just mark the given conditions. So they have given that the time period is 4 seconds and they are asking how much is the time. So basically this is your capital T and this is your small t. So small t is in question. After crossing the mean position, will the displacement, so basically they are giving a condition on displacement 1/3 of its amplitude. So there are certain two conditions given here. I'll should represent that thing in the given format. So they are saying that the time period is 4 seconds and they are saying find out the time when the particle has a displacement of 1/3 of its amplitude. So let's say if this is that particle which is oscillating from its extreme to extreme position, like going back and forth. This is the mean position, this is the amplitude, this is the negative amplitude, and they are saying that what is the time when it goes from its mean position to 1/3 of its amplitude. So this is the first 1/3, this is the second 1/3, and this is the third 1/3. So when the particle reaches this point, how much is the time required to go till this point? Now many people think it okay, so the time period is 4 seconds, so we can just divide that into 4 parts, because time period is the time required from going from mean to extreme, then to mean, and then to negative extreme, and then to mean. So let's say divide it by 4 parts: first, second, third, fourth. So from here, that is the mean position to the extreme position, it will take 1 second, because full is 4 seconds. Then 1 second can be divided into 3 parts, and 0.33, 0.33 and 0.33. So it is not like that, because the velocity is not constant. So the time period is 4 seconds and they are saying that find out time when the displacement is 1/3 of A. So so here is like, since we are doing oscillations, it is very relevant that we'll use equations of oscillations. But suppose if this problem comes into the board, then remember that whenever time is asked, there is this formula x is equal to a sin omega t plus alpha. This is one of the formula which could be used many a times. So we will be using the same formula, x is equal to a sin omega t plus alpha. And since they have mentioned that the particle begins from the mean position, as they have said, crossing the mean position. So we are assuming that since it is crossing the mean position, it is starting from the mean position. So since it is beginning from the mean position, the alpha value is 0. This is something which we have done in our theory course, so when we were doing the theory parts. Now if I put the value of 0 over here, I'll get a sin omega t, because plus 0 is not written. Now in place of x, they have mentioned is 1/3 of a. So 1/3 times a. And omega has a formula of 2 pi by t, so I am replacing omega by 2 pi by t. Then a and a will get cancelled and you will get 1/3 on one side. Sine will remain as sine, but time period is given as 4, so I have put a value of 4 over here. T remains as it is, something we need to get. Now then this 2 and 2 ones are and 2 2s are get cancelled, and you will get pi by 2 times t, and sine remains as it is. And 1/3, if I divide 3 ones are 3, 0.333, then this will be recurring, so that 0.3333 is written over here. Then because this is in radians, I am just converting that into degrees. So pi by 2 radians will convert to 90 degrees, and if you check this out, 0.33, I have not done anything as of yet. Now, and the primary reason for doing this is one, because in some boards the calculators are not allowed. In case if you are not allowed calculator, make sure that you are allowed with the table of sine. Now in the table of sine, the tables of sine is mostly available in degrees. So that's the reason why I have converted this radians into degrees. And if your board allows calculator, then nothing like that, you just can keep on doing it, set your setting on radian, and you can just solve this answers and you can get the values. So now 0.3333 is some number that has to be found out in the table of sine. So I am presuming that the table of sine is something you are familiar with, and because when sine goes on the other side, it will become sine inverse. So this becomes sine inverse of 0.333 equal to 90t. Now if you are not familiar with table of sine, I would request you to go check a table of sine in which you will have some tables and columns where here there are degrees. So starting from 0 to like 90, and here there are numbers like 0 0.1, 0 0.2, 0 0.3 and so on and so forth till 0.9, and then there are mean differences 1, 2, 3, 4 and so on so forth till 5. Okay, so there is this kind of a table of sine. So kindly get that table of sine in case you find it online, or you can get a booklet of that as well in your local markets. And you have to search out of all the numbers over here, you are supposed to search 0.3333. Now if you do not get a number which is 3333, then try to find out the smaller number, then 3333, and then you just add the mean difference to get 3333. But make sure that you never go ahead of this number, and then you just have just connect the dots and you will get the values over here. Okay, in some boards there might be a chance that they will give you the value of this exactly in the question paper as well, but look out, I mean, how well are you comfortable in this thing. Okay, so sine inverse of 0.3333, if I see it from a table of sine, I'll get 19.47 degrees. Now mind you, this is in degrees, this is also in degrees. Now I can take this 90 on the other side, so it will become 19.47 divided by 90. So I get a division by 90. I shift a point over here, this point will be shifting ahead. So if I shifting the denominator left side, so right numerator will also shift to the left side. Then I'll cancel 9 1s are 9, 0.2s are 1s are 6s are 3s are, and I'll get 0.2163 seconds. So this is what the printed answer is also saying, and 0.2163. So it will take only 0.2163 to reach from the mean position to the 1/3 of its amplitude. So this is what the time is. Earlier I showed you how it could have taken 0.33 seconds, but it's not like that. So it's not equally division, because the velocity is maximum at the mean position and minimum at the extreme position. That's the reason we get time as so much. So I hope you have followed this part, and in case you have not subscribed the channel, subscribe the channel. In case you have not done so, share it with people who might get help out of my videos. Thank you so much. Have a nice day. All the best for your exams.